right. How's the mic? Yes? All right.
Do you want this clipped on or are you gonna
I'm gonna stand like here, so we'll just
don't forget the clicker.
don't forget my clicker. All right, here's my clicker. Hey, how are you all doing? I'm here to share some of the findings from the most recent analysis of wildlife trends on the upper Wakulla River, based on, as I just said, weekly surveys along the riverboat tour route, that 1 mile loop when you take the boat ride. There will be a written report forthcoming, but I seem to keep finding other reasons to do other things. But when it does, it'll be posted on the Wakulla Springs Alliance website. We've got a very large depository of scientific information there. And if you want to see that at some time, you can poke around and look at it. But in particular, tonight, I want to focus on the altered food web that is emerging at Wakulla over the last several years, where crayfish are becoming more abundant and the small fish are becoming less abundant, or we have at least determined that by observing who's eating what. All right, let's see. This shift in the food web is therefore favoring the birds that eat crayfish at the expense of the birds that eat small fish. So on this slide, you'll see 4 of our crayfish eaters, the pied-billed grebe and the hooded merganser, are pretty much obligate crayfish eaters. I've never seen them eat anything else. The white ibis and the yellow-crowned night heron eat other things too, but we very, very often see them eating crayfish. The anhinga and the double-crested cormorant are predominantly fish eaters, and if you look up what their preferred diet is, you will see it says fish. But I just took a boat ride about a month ago with one of the newer rangers, and a double-crested cormorant popped up with a crayfish in its mouth, and he said, "Crayfish are the favorite food of the double-crested cormorant." And I said to myself, well, that's because that's what's for dinner. So here it is. This is the main entree at this point. This is the peninsula crayfish, and near as I can tell from the data that are available, this is the only species in the Wakulla River. But before we unravel the crayfish story, I want to back up and take a look at the long-term wildlife trends in the Wakulla River that we've been analyzing since 1992. So the park's been conducting wildlife surveys, therefore, for over 30 years. It started with monthly surveys that were conducted by park rangers until November 2012, when Bob Thompson, who is sitting right there, having recently retired, volunteered to start a weekly wildlife survey using volunteers. And you can see that the data points suddenly get very dense right after 2012. That's because we've shifted from monthly to weekly data. So we have a long-term database, and what this graph depicts on the horizontal axis is total animal counts per survey. So just all the critters, how many white ibis, how many hooded mergansers, how many alligators, etc. That's the total number of critters counted on any given survey. And the red line is a regression line fitted to the data. And if you know your statistics, you can see that it was statistically significant. And if you don't, you just have to trust me that that's what those numbers say. So we have a statistically significant long-term trend in total animal abundance going on over more than 30 years of collecting data. I'm going to focus tonight on the wildlife abundance trend starting in 2012 through June 2024. So this is a graph similarly set up of that, and you can see from the statistics the F probability is such that it's not significant at the 95% level, So I've drawn a trend line through it, but there's not a significant trend. So it's not going down, it's not going up. It's more or less perhaps indicating that we've attained some kind of a new balance in the carrying capacity of the ecosystem. So I like to refer to this time period post 2012 as the post hydrilla management period, and I'll explain that shortly. But two things demark this change. The first is in November of 2012, the upgraded Tallahassee TP Smith wastewater treatment facility went fully operational after several years of upgrading. And as a result, the total amount of nitrate nitrogen being discharged at the spray field and finding its way to Wakulla Spring dropped 73% from 2011 to 2012. This was the only major significant decrease in nitrogen loading to the spring. And May 2012 marks the last annual herbicide treatment that was being conducted by the park staff to control the invasive hydrilla that was the bane of the ecosystem for many years. The reason that May 2012 was the last year that they needed to treat the hydrilla is twofold. One is the reduction in nitrogen coming in from the spray field. The other is that the manatee, which had increased in numbers dramatically, were grazing the hydrilla, and the combination of less nutrients and heavy grazing kept the hydrilla at bay, and we've no longer needed to apply herbicides since 2012. So the ecosystem of today for the upper river is substantially different from what was there in 1992 when the park started conducting these wildlife surveys. And this is the result of a whole string of perturbations to the system. The first was the hydrilla invasion from 1997 to 2000. The second was the beginning of herbicide treatments in 2002, which, as I just said, ran through 2012. The third was the sustained presence of manatees. They first arrived in numbers worth counting in 2003 and have been there ever since. The Tallahassee wastewater treatment facility upgrade that I just mentioned. And then most recently, two disturbances, a massive die-off of emergent plant habitat, which we'll talk about shortly, that started in 2021 and ran for 2 years, and the disintegration of the Bulrush Island, which is that island at the end of the tour boat route when you make that turn and come back up the other way. We call that the Bulrush Island, and we'll say more about that momentarily also. So the hydrilla invasion, 1997, April 1997 supposedly is when it was first observed near the boat dock. By December of that year, it had spread downriver to the first turn on the tour boat route, which is about a quarter mile from the boat dock. By 2000, the hydrilla had spread 1 mile downstream from the tour boat turn. So it was 2 miles of river covered in hydrilla. And you can see the picture in the upper left corner there was taken in 1998. That's the swimming area. And the other picture, which doesn't have a photo credit, but I'm pretty sure that's a Bob Thompson hydrilla photo right there. Gives you an idea what happy hydrilla looks like. So the Park Service started out trying to remove it manually. They couldn't get the roots out of the sediment, so they were just yanking on it. And this is an extraordinary picture of a couple of, a lifeguard and somebody else moving a barge full of hydrilla. That didn't work. And to make matters worse, the removal that they were using, they ended up using acne, what do you call those things? Well, we call them lawnmowers, but the devices to cut it. Say it again? No, Zambonis make ice. Anyways, they're the devices that are used to cut up aquatic vegetation. There was a lot of bycatch as a result, and Scott Savory, who was the park biologist at the time, and the DEP folks decided it wasn't working, and they were losing lots of critters in the process. So they made the difficult decision to switch to herbicide treatment, and the first large-scale herbicide application was conducted in April of 2002. And that shows you the buoy line that they use to spread out, and they discharge the stuff into the water. So what happened with the herbicide treatment? Well, the initial application in April 2002 killed off estimated 70 to 80% of the standing crop. Was killed off by that first slug of herbicide. Again, just above the sediment level. It was not killing the plants. The roots were being retained in the sediment. The herbicides were not selective for hydrilla, so they were also affecting the native submerged aquatic vegetation, or SAV, to the detriment of those plants. The die-off from the herbicide treatment was very rapid, and so a huge mass of dead plant material washed down the river. It actually scoured the bottom of the river and scoured away some of the sediment, so we lost some of the native submerged aquatic vegetation because it got uprooted, but it also started eroding the channel, and we're still dealing with the after effects of that even today. The hydrilla would grow back over the course of the next several months. The native SAV would grow back over the next several months, and by the next spring, there'd be enough hydrilla that we would have to apply herbicides again. But in the meantime, algae, which could proliferate much more quickly than the macrophytes could grow back, started to take over the habitat. All this was nitrogen was there, and nobody was using it. So we began to see huge mats of algae taking over the ecosystem. That's very starkly revealed by this comparison of photographs. The photograph on the left is from the State Archive. It was taken in 1962, and it is titled Spearfishing for Trash Fish, but it was taken in the Spring Basin. And this picture was taken by David Moynihan to replicate that same scene in 2013. This was about as bad as it got. It was solid masses of algal mats covering just about everything. So by 2012, the SAV community was drastically altered. Prior to the hydrilla invasion in '97, this is what the river looked like. So this is a low altitude photo looking downriver, the springs in the foreground. This was taken in 1967 also. And that dark color that you see, that is all either Vallisneria americana, the so-called eelgrass, or Sagittaria curtsiana, known as strapleaf, and a bunch of other names for it. All that dark color that you see there is plant cover. The only area that looks like bare sediment is the swimming area, and that's because Ed Ball had his folks going out there yanking it up out of the bottom so the swimmers wouldn't get itchy ankles. And of course, along with these two major submerged grasses were a whole lot of other native plants such as red ludwigia, Illinois pondweed, muskgrass, and southern naiad, among others. So what do we know about the status of the submerged aquatic vegetation, which forms the foundation of the food web? Well, Sean McGlynn and Scott Savory, who I mentioned was the park biologist, then started quarterly submerged aquatic vegetation surveying at 7 transects along the upper river. And you can see there where those transects were. And taking a look at the data that have been collected since that time through June of '24 reveals a pretty stable situation. So in the first row, we have the Sagittaria, the strapleaf, submerged aquatic grass. That has the highest percent mean cover of 32% and shows a statistically significant increase over time. So that particular native species is increasing, but the algae have been pretty stable at 30% of mean cover. We've had bare sediment pretty stable at 24%. and hydrilla at just 8%, and the Vallisneria, the American eelgrass, at 2%. So if you add the algae and the bare sediment, 54% of the bottom along these transects is either bare or covered with algae. It should be covered with Sagittaria and Vallisneria and the other goodies. So the implication from this is that the base of the food web has changed. So presumably the critters that eat that stuff have changed. And we're going to see that when we see the birds and what the birds are eating and what the birds are doing. And we can infer that the fish populations must have declined as a result of these changes, because we see declines in the major fish-eating species. To me, the most telling evidence is looking at nesting behavior. There were as many as 4 or 5 active osprey nests on just that upper mile at one point in time. And this is a quote from Bob Thompson. And I'm sure you remember you told me that, right? But in any case, that's the source of my data on that one. But I started driving riverboats in 2013. And as of 2015, there were 3 active osprey nests on that tour boat route. Now we have 1, and they don't always successfully fledge young. So it's not big numbers, but going from 5 to 1 that's not always successful tells you a lot, because osprey eat a lot of fish. So there were a lot of fish way back when, and there aren't very many fish now. The other critter that prefers fish that's worth noting is the anhinga. In 2015, I remember counting 5 active nests, 2015, and for several years thereafter. But by 2017, we were down to 1 active nest, and now it's been 1 or 2 each year. So that tells me there's not enough fish. And so it's crayfish. That's what's for dinner at this point. So why do crayfish proliferate? Well, crayfish eat algae. And now 30% of the bottom is covered with algae. Crayfish also eat detritus, or dead organic matter, and algae turns into dead organic matter very rapidly. So the 2 things that crayfish like are there in abundance. And so it makes sense that this change in the food web would favor the crayfish. Well, what are the implications for our critters here? So I'm going to give you a moment to understand this chart. And I can't point too well and look up at the same time because I have bifocals. But if you look at the x-axis, those are counts per year, change in counts per year for a given species. It's equivalent to the slope of the regression line. So anything to the left in red represent decreases in the counts per year for that species over the post-hydrilla management period from 2012 to June of 2024. Anything green, those species have exhibited statistically significant increases in counts per year. And in between are some little tiny polygons that are yellow. And for those species, the change is very small and it's not statistically significant. So what we see here is that 3 of the 4 species that predominantly eat crayfish have exhibited significant positive increases: the hooded merganser, the white ibis, and the yellow-crowned night heron. The 4th is the pied-billed grebe, and the pied-billed grebe is actually showing a statistically significant decrease in counts per year over this time period. We'll say more about each of these over time. The double-crested cormorant also has experienced a significant increase and appears to be adapting to the change in what's for dinner. As I've mentioned, they're starting to eat crayfish. And the anhinga, which had exhibited an increasing trend through May of 2021, has now leveled off. they are also eating crayfish, but maybe that's not so good for anhinga health and reproduction as maybe it is for cormorants. So let's take a look at the pied-bill grebe. This is my favorite crayfish eater. They are so small, they're so smart, and they swallow those crayfish head first. They are year-round breeders on the river, but their numbers are augmented in the wintertime by an influx of migrants from the north. So if we were to look at their seasonal distribution, we see every winter that the numbers go up substantially. They feed almost exclusively on crayfish, and I say that only because I'd never say always and always say never. But I have never seen one eat anything but a crayfish. Bob, have you ever seen one eat anything else? No. Yeah, so we're pretty sure that's all they eat. They're especially adapted to eating crayfish. They also ingest their own feathers, and at any point in time, a pied-bill grebe's belly can be as much as a quarter full of feathers. When they eat those crayfish, the hard shell parts get tangled up in the feathers and form pellets, and they disgorge them just like an owl or an eagle or a hawk will discharge pellets of bone and fur. I like to tell my riverboat tour guide visitors that means if you're a baby pied-bill grebe, mom and dad are going to feed you crayfish and feathers. But as shown in this next series of pictures that Bob Thompson took, they're really amazing because they grab the crayfish, then they nip off both of the claws, then they flip it around so it goes down head first. If you've ever tried to swallow a crayfish whole, you know head first is a lot easier than tail first. So they have figured that out. So how are our pied-bill grebes doing? This is the graph of pied-bill grebe counts per survey from 2012 through May 2021. That's the previous period of analysis before this update. And you see there's no significant trend at that time, which suggested to me that they had probably figured out their carrying capacity. And I say that whimsically, they don't figure it out, but it suggests that they had attained carrying capacity in terms of the number of pied-bill grebes that could be sustained with what was available in terms of crayfish. When we extend the period of analysis now to June of 2024, we now have a statistically significant decreasing trend. And if you look all the way over to the right, mid 2022, all of a sudden the numbers just drop precipitously. That decline is most likely the result of two of those ecosystem perturbations that I mentioned previously. One is the demise of the bulrush island, and the other is the extensive die-off of emergent plant habitat along the river margins that occurred in the summers of 2021 and 2022. Let's take a look at the bulrush island. Here's a Google Earth photo of the bulrush island. And if you follow along from left to right, you come down to nearly the end is where the boats turn around and pass between that little round island and the bigger island. So that's what the bulrush island looked like in 2016. I was away from Tallahassee for most of the year of 2017 to 2018. No, that's not right. 2018 to 2019. But whenever I came back, Jackie Turner would let me drive riverboats, so I would go out. And when I came back in 2018, I said, the bulrush island's coming apart, and not everybody had picked up on it yet because they were seeing it every day. We call it the bulrush island because the dominant plant was the California bulrush, with an outer margin of knotweed and water hemlock and pickerel weed and a lot of stuff tangled up in between. And down at the downriver end, where there's higher ground, cattails were on the upper elevations. This island was in part, if not entirely, created from dredge spoil when Ed Ball dredged that back channel. So his new big tour boats that he bought in '66 could turn around and go back up the river without having to do a 360, well, a 180 in the middle of the river. Here's one of the last, oh, there's the turnaround. Ta-da. I took this picture in November of 2024, one of the last remaining stands of bulrushes in that whole island. And virtually all the stems are dead. There's maybe a few with a little bit of green in them. So again, here's what it looked like in 2016. Here's what it looked like in 2018 when I came up to drive riverboats, and you can see there's some holes starting to form in the middle of the island, and those holes eventually grew to the point. Oh, I pushed the wrong button, sorry. There's some of those holes. Here's what it looked like a year ago, April 2024. And I can tell you that if we had a Google Earth photo now, it'd be at least 50% less than that. There's almost nothing left, just little pockets of habitat. We don't know why this has happened. My only hypothesis is that it might have something to do with periodic salinity spikes in the water coming out of the vent at the spring at times when the flow of groundwater from the south moves up to Wakulla Springs from the Spring Creek Spring system, which is connected to Wakulla Springs. And the water quality sampling that Sean McGlynn's been doing weekly since 2015 has shown periodic spikes in salinity. We know that the bulrushes are not very tolerant of salinity, so maybe it's that, but we really don't know, and nobody's gone out and tried to figure out what's going on. So that's important because that island provided an immense amount of habitat for pied-billed grebes and common gallinule and our little pair of least bitterns that comes back every year and nests either on the far side of the river or on the upstream end of that island. The related situation has to do with the emergent vegetation die-off that happened in May of 2021. We observed die-off of 3 different species: knotweed, also known as smartweed, which is the plant in the foreground, and you can see all those reddish brown stems. That is very unhappy knotweed. And behind that, on the left, you can see some yellowing leaves. That's water hemlock, which is the next layer back in terms of water depth. And then in between, and not shown in this picture, is pickerel weed. All 3 of those species showed substantial declines in May. And in fact, we had rafts of it bigger than this table floating down the river. We, Patty Wilbur and I, Patty's the current park biologist, took a canoe and paddled the full 3 miles in the park, and we saw evidence of the knotweed distress throughout the 3 miles. We went under the bridge and down the river further, and it continued down the river. I went and looked at all the nearby streams, and it wasn't happening anywhere else. It was just happening on the Wakulla River. We never figured out what the cause was. We hypothesized there'd been some kind of herbicide discharge upstream and into the groundwater, but attempts to analyze the plants and find something that would prove that was the case were futile. So by September of 2021, some of the surviving knotweed began to bounce back, but by that time, I just took a Google Earth photo and estimated where all the losses had been and used the measuring tools. I estimated about 4/10 of an acre of lost habitat in the upper river at that time. Algae began to move in where the plants had died and colonized the sediments, and then other submerged plants like water lily and red Ludwigia and parrot feather moved in. But then we had a second die-off, not so extensive, in May of 2022. So that's the explanation for the precipitous drop in pied-billed grebe numbers that we saw beginning in April of 2022. So let's look at our other crayfish eaters here where the story is more positive. Yellow-crowned night herons also breed on the upper Wakulla River. They used to be that the adults would migrate in the wintertime and we just have juveniles, and I guess maybe because of climate change, not sure what, but now we're seeing adults stick around to a greater extent in the wintertime. They're not present in really large numbers, but they have exhibited a statistically significant increase in numbers nonetheless over this time period from 2012 through June of 2024. So they're doing okay. How about our white ibis? Another fine Bob Thompson photo with a crayfish. Now, my observation is the ibis are not too particular about the claws. I like the claws myself. I'm pretty sure they eat the whole crayfish. They're observed on the upper river year round, but in very small numbers in the summertime, mostly juveniles. In the wintertime, we have a big influx of adults. And from what I can understand, it's a regional migration. They nest in the general vicinity, but for some reason they come to Wakulla Springs and hang out together in the wintertime. And you can see that here. This is the monthly means for white ibis, starting with J for January on the left through D for December on the far right. And you see the much higher counts in the winter months. They are also happy and showing a statistically significant increase over this time period since 2012. Then we have the hooded merganser, another one of these species that seems to be uniquely tied to crayfish for their diet. They are exclusively winter visitors. We only see them during the winter months, and they come in very large numbers. On this particular chart, that one little dot way up in the upper right corner is a count of 296. That's a single count on a single day. So sometimes there are a lot of hooded mergansers. And they too are doing fine. Oh, yes, there's the graph. I got ahead of myself. So I got to wondering if the pied-billed grebe population has plummeted, have the other crayfish eaters taken advantage of reduced competition? So I made a chart, and this starts out with the three species that are doing well. The bottom orange or red line is the yellow-crowned night heron. The blue line in the middle is the hooded merganser. And the green, dark green line across the top is the white ibis. And you can see them all exhibiting increases that start in 2021 at the same time that the pied-billed grebe demise began. And in fact, if we lay the pied-billed grebe chart over the top of that, you can see the light green precipitous drop starting in 2021. But there's some other interesting things going on here. If you compare the light green trend for the pied-billed grebe with the trends for the white ibis and the hooded merganser, you can see a pretty obvious inverse relationship. When the pied-billed grebe numbers go up in 2018, the numbers of hooded mergansers and white ibis go down in 2018. And you can see that the increases for the ibis and the hooded merganser track very well with the decrease in the pied-billed grebes. The other thing that I find interesting about this is if we back up for a minute and get those grebes out of there, if you look at the ibis and the hooded merganser, they seem to be nearly parallel with each other. So what's good for the ibis in any given season seems to be good for the hooded mergansers, and they seem to be able to share the crayfish without undue detriment to each other. I did some Pearson's R correlations, and these relationships are all statistically significant. So it's real. That's what's going on there. So it's going to be interesting to see how these relationships shift if the pied-billed grebe starts to make a comeback. Will we see corresponding declines in the ibis and the hooded mergansers and the yellow-crowned night herons, who are down there, not very large in numbers, but also evidently taking advantage of the opportunities. In just this past year, we did see a doubling of our counts between April and June and July and September, which might give rise to some hope, but I think that's probably just the juveniles that were hatched out and came along. We have seen, and I don't have those numbers calculated, but just from going out on the river the last 2 months, we have seen more winter pied-billed grebes this year than the 2 preceding winters. That also might be a positive sign. But I don't think that we're going to see the numbers that we've seen before. So on your left is the monthly means for the period June 2019 to May 2020 for pied-billed grebes. And on the right are those same numbers for June 2023 through May 2024. We're talking about order of magnitude decrease in numbers here. The knotweed is beginning to come back in some places, but in many places after it died, the sediments eroded and it's too deep. It's not going to reestablish itself anytime soon. I think we're likely to see some improvement in the pied-billed grebes, but meanwhile, we've got the anhinga and the double-crested cormorants are developing a taste for crayfish. So that's going to potentially complicate the competition even further. And we'll just have to see if these two become important parts of the whole crayfish consumption situation. Well, that's where I end up with an anhinga and a double-crested cormorant, a couple of Bob Thompson's excellent photographs. We have time for questions. Okay. Yes, Noel?
Oh, yeah, that's.
We need to get you on the mic for the Zoomers.
Has there been any SAV projects within the park to reestablish the lost population?
My favorite question. Thanks for asking that. And I almost asked you something about that. Noel's working for the Northwest Florida Water Management District, and I've had several conversations with Kathleen Coates, with whom Noel works, about possible revegetation projects there. And there's been some interest in it at I think at the Water Management District level. There was a for-profit revegetation outfit that got a research permit a couple of years ago to look at the feasibility of potentially doing something on the Wakulla River. And I've lost track of that. I asked Patty Wilbur, who's the park biologist, about it, but I haven't asked her recently. It seems like it could be done. It's been done successfully on the down in Crystal River. They have learned down there that you don't try to plant eelgrass in the winter time when the manatee are there in large numbers. In fact, they had manatee taking the plantlets out of the hands of the divers while they were trying to plant them. So they've modified, but there have been successful revegetation projects elsewhere in the state. So it does seem plausible. And Sean McGlynn and Cal Jameson have been doing weekly surveys, monthly surveys, using a different protocol. They're not looking at the same transects that the quarterly surveys use. They say they've seen some evidence of some of the eelgrass or springtape grass spreading. So there does appear to be some improvement. but our transect data don't show any improvement. So I still think it's probably the most significant thing we could do to that ecosystem is consider an SAV restoration project. Yes,
I had a
Catherine?
question. Oh, I'm not clear on why the vegetation die-off along the sides of the river, why that is affecting the pinebill grebes, or
So where's my clicker?
did I miss something?
This knotweed here is, there's not very much of it, but in many places, the knotweed zone is 3, 4, even 5 feet wide. That's where the pinebill grebes nest, back up in there. And that's where they hide from predators. So take away the nesting habitat.
Okay.
You don't have
okay.
very many pinebill grebes around. There's one big patch that's somehow escaped. If you're standing at the boat dock and looking across the river at about a 2 o'clock angle, there's a big swamp back in there where the boats don't go, and the knotweed back in there seems to have escaped to a greater extent than whatever it was that caused the problem. That's where we've seen some babies coming out of there. So it's pretty clear that it's the knotweed is the critical thing. The common gallinule use that for cover and nesting too, but their numbers have been, I think, let's look at the common gallinule. They're in the yellow range. So they had been declining and they've leveled off, which again suggests maybe they've found the right carrying capacity level. So less sensitive to this habitat loss than the grebes. Other questions? Bob Thompson, let Kathleen bring you the mic so the Zoomers can hear you.
That'll be on the report.
And is anybody monitoring the Zoom for questions?
I just thought I would add, I've observed where the pinebill grebes nest, and it's right at the surface of the water. They'll collect some aquatic plants and make a quote unquote nest right at the water's level. And as you drive by in a boat looking down, you can see the eggs in the nest. And I've often wondered, how would this ever work? I mean, the river level goes up, it goes down, and the eggs are easily seen. I would think the predators would hit it. But anyway, that's my observation. You talked about the smart grass. To the extent that it would be emergent, it would tend to hide the eggs.
Right. So if any of you missed that, Bob's describing the nests that he's observed, and they're basically floating nests, aren't they?
Yes.
Yeah, they're floating nests back in the smartweed, knotweed. And I remember coming around that turn and starting to come up the river by the Bulrush Island where there used to be a lot of that, and you'd see one grebe would come out and make an alarm call, and we knew back inside the other grebe was in there with the babies. And sometimes they'd come out and the babies would be riding on their backs. That's the best part. Other questions or contributions are right behind you, Kathleen.
Hi, I kind of have an observation and then also a broader question here, but it's really interesting to see the parallel trends for the mergansers and the white ibis. I would assume what's happening there is that they're basically niche partitioned, right? So the ibis is wading in shallow water, the merganser is diving in deeper water. They're eating the same thing, but they're not affecting each other because they're in different parts of the river ecosystem. Although what's interesting there is that the grebe is also a diver. So I would be interested to see why the merganser and the ibis don't compete, but the grebe and the white ibis do.
Right.
So that was just an observation I had there. But then my broader question is simply, what, in your opinion, are the management implications for a lot of these trends, because certainly it seems like there is a new equilibrium reached. And that, short of like the SAV stuff that we talked about, the algae are also going to be part of that equilibrium. So just simply, in your opinion, if you were like the park manager or the river keeper, like what would be the actions you would take for management based off of a lot of these results?
If I were the park manager, what management initiatives would I be trying to take? Honestly, the only thing I think that might make a difference is SAV restoration. I don't see any way to restore the knotweed habitat. It's starting to come back where it can, and it'll do what it'll do. Like I said, with the bulrush island, it's pretty much gone at this point, and it was, and now it isn't. And part of the implications of that is that island had knotweed growing all the way around it, so that we lost. That's not coming back at all. The niche or niche partitioning, I grew up on niche, but I'm from North Germany. Is a great observation, and it makes me wonder if the grebes are diving in both shallow water and deep water, and the mergansers are staying out near the center of the river. And I don't know, Bob might have some recollections about where we've seen diving. I'm thinking the only place I see mergansers dive is out more in the center of the river, and the grebes seem to go down just about anywhere. So that's a really great observation. I appreciate that a lot. Yes, sir. Are any limpkins coming back? Well, I would rephrase that as have any limpkins come back. We see them periodically, one at a time. I think a couple years ago we had 2 for a week or so. They show up, they eat as many mussels as they can find. There are not enough apple snails. I haven't seen any eating apple snails on the upper river. We see all these empty mussel shells, and then they go. Theory is they may be juveniles that are looking for a place to set up shop, and they eat at the mussel bar and they move on. There's been one there the last few weeks, but they don't. There's no pattern to it at all. And if you want to know about what happened to the limpkins, that's a whole nother slideshow. Yeah, Donna.
Oops, hang on.
Oh, wait for the mic.
What's happened to the turtles and the coots?
What's happened to the turtles and the coots? Notice if you look closely that after those titles, it says times 1,000. So the graph actually extends over into the next building from here. They've really, the drop has been precipitous. Turtles, I don't give much concern to, because the number of turtles we count depends so much on the water clarity. And the water has gotten darker, so that might have something to do with it. But beyond that, I don't know. But it might also be related to the loss of SAV, submerged aquatic vegetation. The coots, I think it's probably some kind of exogenous factor. They're just here in the wintertime, and something's affected how many coots are coming down from up north. That's all I can guess. We were down to 2 coots for a number of years, and this year I think we have 4 or 5. But there used to be 40 or 50 of them. That gentleman right there. Wait for the mic.
Sorry.
Would you explain a little bit more what you were talking about with the salinity level, and how far was it from the head of the spring? What was all that
So
about?
let's see, I have to use my hands here. So here's Wakulla Springs, here's Tallahassee, here's Spring Creek. The elevation difference between the spring head at Wakulla and sea level is about 5 feet. Not a whole lot of difference. When we have periods of prolonged drought and reduced flow, the whole system drains from north to south generally. When we have long periods of reduced rainfall, that head differential is reduced because there's not a lot of water in the aquifer, and water from Spring Creek flows north, salt water flows north up into the system and can reach Wakulla Springs. Meanwhile, sea level is rising and reducing that gradient at the same time. So it's getting smaller and smaller, which means it's getting easier and easier for salt water to work its way up into the spring.
It could turn brackish.
Say it again?
It could turn more brackish.
Oh, well, brackish, yeah, it's not salt water if you're looking at chloride concentrations.
Yeah.
But the chloride concentrations are in the range of the sensitivity of the bulrush, near as I can tell from a fair amount of Google scholaring. Yeah, Bob.
And correct me if I'm wrong, the salinity spike that you've talked about, it's in the caves. The salinity is coming in,
Yes,
in
right.
the caves.
Right.
And-
Yeah, we're
Yeah.
talking about the water that's being discharged at the spring
Yes.
is increased in salinity because the water in the aquifer is flowing north from Spring Creek all the way to Wakulla Springs and mixing in with the water that's coming down from the north. I changed directions. Water from the north, they're actually coming together as a result of that. Yeah. Noel. What? Mike for Noel.
Hi, Kathleen. So with the SAVs, do you have any historical data about biological sampling for aquatic macroinvertebrates within the SAV communities? And since that's changed so much, have you done any comparison on that?
There's no fish data other than one, I think, survey that was done in the
So there's certainly
70s.
no aquatic
There's no
macroinvertebrate.
aquatic macrophytes. DEP does periodic. Oh, I can never remember the name for that. They count certain not paraphyton invertebrates.
The macroinvertebrates.
Macro,
Yeah.
yeah. Well, macro meaning I
Small,
think,
like odonates
yeah, I
and
think some of them are
trichoptera.
microinvertebrates or mesoinvertebrates. Yeah, but that yeah, I've not looked at those data because they go into an index,
Yep.
and so I've seen the index numbers. I haven't seen the raw counts. That might be worth taking a look at.
Yeah, I was thinking so because that's what the small fish eat, and
Yeah.
they also use the
Right.
SAV as habitat, so
Yeah.
it might be from bottom up.
Right. So a casual observation. I started training to be a riverboat tour guide in August of 2013. And at that time, if you went down to the boat dock and looked in the water, there were masses of those little tiny black helical snails covering the sediments. If you go down there now, there are none.
No.
So there's your macroinvertebrate data right there. But again, Cal Jamieson said he's starting to see some coming back in some places, but those shifts, I think probably residuals from the herbicide treatment, but it's hard to know. Anybody else? Did we check to see if there was anybody on Zoom that had a question?
No questions from.
No
Zoom
questions from
audience.
Zoom land. Okay. Well, thanks. It's lovely to talk to it's lovely to talk to people who care and are interested. So I stopped screen sharing and then give you